So let's begin implementing the finite stack based on array. So we are going to define a class named fstack where we are going to create an array and store data as you do push and pop. So as a test-driven development, let's create the test code first. So before doing so, let me create empty directory for lab02. Move in there, main programming to do some cout, and then something else you could do, include the IO stream, namespace std, the main, return 0 here. So we are going to define a class named fstack, finite stack. So we include the interface.h file of that. Then when you create a stack variable or object, the object at this moment is a variable of a class type. So stack1 we create, then we specify the size of the array within the stack object. And then at the very beginning, we should assert that the stack should be empty at the very beginning. True. Then checking with the true is optional, so it should be empty. Also, we should assert that stack is not full at the very beginning. So let's implement just up to here. So in another terminal, let's define stack interface part.h part. So we do include if not def fstack h define, and if then we define class named fstack. So here as a private member, let's have a top of stack, which indicates where is the last data entered, which stores the index of the array. And then we are going to allocate an array based on the number provided when we define the stack variable. So 5, so for example, then that should be the capacity of the array. So let's define a capacity. So whatever is provided when a variable is created through constructor. So let's store that information, capacity of the array. And then we are going to create an array based on the capacity information. That should be done through dynamic memory allocation using new operator. And for this stack implementation, at this moment we will assume data is integer only. So in later we are going to learn how to do so for any data type, but at this moment I just focus on integer data types only. So we need to store integer data in the integer array. Since we are going to create an array dynamically based on the capacity information, let's have a pointer to the array at this moment. Then as a public member, we need to have a constructor. Constructor takes the capacity information, the beginning, but as you know, as you remember, in a function prototype, the parameter name is optional, so we don't have to give a name of the parameter. Then we are going to implement two functions, empty and the full. So bool empty. And then this function does not change any member variables like a TOS, capacity, and P array. So const function should be good choice. Then full, also it's a const function. So let me use another terminal to implement some of the member functions defined so far. So here we are going to include interface definition of a fstack class. Then first constructor, class name, function name, and then capacity is provided. So here we are going to use the initializer list. So here with the colon, so parameter C is for capacity, so let's initialize capacity by C. And then TOS, we need to consider a few things here. So what would be the good value for TOS? Prior to that, let me do some other things first. Here we need to create an array dynamically with the capacity information. So P array is a pointer. There I can create the integer array with this many elements. So keyword new and int, and then capacity. So array is created dynamically, and then the first element address is stored. So address of the array is stored in a variable named P array there. So at this moment, we are going to create an array with a capacity number of elements. So index 0, 1, and so on. At the very beginning, the stack is empty, but if you do push once, then push once, the very first data will be stored at index 0. At that moment, TOS will be 0. But if I do push again, then what I'm going to do is I need to increment TOS 1, and then there I'm going to store data. So what would be the best value of TOS when stack is empty? When we do push, we are going to increment it and then use it as index location of the storage. So if TOS is a -1 at the beginning, then the very first push, we are going to increment it. Then it becomes a 0, and then we store that. So the TOS as a initial value, the -1 will be the best choice for that. So let's initialize TOS as a -1. So that's the constructor part. Then let's take a look at the main application code. So here as a 5 is provided, 5 is stored in capacity, and then we are going to create an integer array with 5 elements there. So two other functions we implement is a bool empty const. Then we need to return true or false based on the emptiness of the stack. So how do we know if a stack is empty or not? So when we create the stack at the very beginning, the TOS is -1. So by checking value of TOS -1, we can tell whether it's empty or not. Full function is how do we know the stack is full or not? And TOS will increment. Suppose we have a capacity of 5, then the last index of the array should be 1 less capacity, which is 4. So if TOS is 4, meaning that the arrays are fully utilized. So if TOS is the same as capacity -1, then that's a sign of fullness of the stack. So using those, we can test the very simple code developed so far. First, the assert function is in C assert library, so we need to add that. Then let's create make a file. Make a file. Our ultimate goal is a.out. Since we have two CPP files, fstack.cpp, and then we need to translate it into .o, and the main CPP should be translated into .o. Then command is putting those two together is how to produce a.out. And then fstack.o, we need .h, .cpp. Using those two, we can compile only fstack.cpp. Then it produces fstack.o. And then main.o, we need the main.cpp, of course. And then in main.cpp, we have included fstack.h. So there's a dependency. Then compile only main.cpp is there. So that's the dependency information in Makefile. Now we are ready to compile. So those compilation is done successfully. Then as I run that, the both assertion succeeded. So there is no error comes out. Now we are ready to implement a major operations here, a push and the pop in next video.